Inherent risk is undertaken using contingency estimator. The first step is to import an estimate, and then the various estimates will appear in contingency estimator's project screen. We open a project. One of the pages of that estimate worksheet is drainage. There's the description of items, unit, and obviously our quantities and rates. A small workshop needs to be held between the estimator, project manager, normally designer, and quite often customer. The workshop undertakes 2 items. It discusses each item and thereby looks at the variability of quantities and rates, and also the discussion distills where there might be errors in scope or scope elements that are missing. So the workshop discussion is very important. Entering data is very easy. So there might be 4 of those, probably maybe 6. Price might be 4,500 as a minimum rate, and probably 6,000 as a top rate, and so forth through the estimate. As we review the estimate, it may be that there are items that are no longer required or required, so we can quite quickly add a new item or delete a new item to ensure it reflects the current thinking for drainage, and we can move on to track work, earthworks, etc. A simulation is easily run purely for this particular page by running a simulation for the group. That derives 3 reports: a histogram, a listing of the input data, and a tornado diagram. The histogram shows the cumulative values of 1,000 iterations, and if we zoom in to the bottom, you can see that our estimate item total original estimate is 148,000, P50 contingency nearly 4,000, and a P90 contingency of 12,000. So the total cost for drainage is likely to be about 152,000. It'll be a little bit above or a little bit below. If I want to be conservative, 160,000 is what I would use. The tornado report is particularly useful because it shows those items that I need to work on next. So these items here are driving the bottom line, and if I can get more accurate data in terms of installing concrete channel, maybe some quotes, then I will reduce the amount of uncertainty and therefore the amount of contingency I need to cover inherent risk. And that largely is all there is to it. I go through track work, earthwork, doing the same sort of exercise, and then I can run a simulation for a project. I can run 1,000 iterations, which is the default. If the information or data is moving around a bit too quickly, then I can go up to 10,000 iterations. And some organizations prefer a P80 rather than a P90 or some other value. So that's probably as simple as is possible to run a Monte Carlo simulation for inherent risk. The beauty about this is that it can all be operated by the project manager. He or she is the one owning the estimate, single source of truth, which is very important, and at any time can update the data as new information comes in. I look forward to catching up on the next video.